Deathly gravitational embrace. Researcher predicts what awaits our life-friendly Milky Way galaxy. A product of a massive bang, our galaxy is the only known one supporting life and is expected to sink into oblivion in a pretty similar way. This is on Sputnik News. Milky Way, just one of a myriad of galaxies scattering around ever-expanding universe, with NASA's Hubble Space Telescope putting the total number of those it has managed to map already at around 100 billion. 100 billion galaxies. Despite the Milky Way, where life has famously uniquely emerged as we know it, being the subject of numerous studies, it seems that newer and fresher ones will never cease to appear. In the new book release titled Milky Way Owner's Workshop Manual, scientist Gemma Lavender, member of the Royal Astronomical Society, who is an astrophysicist and writer, gives reasons why common interest for the Milky Way continues to be on the rise. She says it looks like a river of light, but train a telescope on part of it and you will see that it's constructed from countless stars. This is what she explains before continuing in incessantly romantic terms. She says, look even closer and you'll see that among the stars are pockets of gas and dust. Some are colorful, others are dark and hidden. Astronomers say that the Milky Way is about 13.5 billion years old, but it took a long time for the galaxy to arrive at its current shape, of course. Moving on to explain the intriguing hypothesis, which is now commonly believed, researchers say that about 4 to 5 billion years from now, the Milky Way's neighbor, the Andromeda galaxy, will come careening and crashing into us. So the two galaxies, the Milky Way and the Andromeda, will crash into each other. The authors contend that the final collision will create new galaxies, sometimes referred to as the Milkomeda, Milky Way, Andromeda, Milkomeda. They said our two galaxies will start ripping chunks out of each other, tidal streams trailing away, their central bars destroyed, and their spiral arms twisted this way and that. And she is not totally ruling out a second collision event. She says perhaps there will be a second close encounter after, as they spiral towards each other, and then in this deathly gravitational embrace, the two disrupted galaxies will ultimately spin back around and literally fall into each other's arms, and their stars and gas becoming mingled. The astrophysics of this is depicted in the minutest scale. Lavender says the molecular gas clouds will meet head-on, and huge bursts of star formation will ignite. The Milky Way is a product of the Big Bang that occurred 13.5 billion years ago. It's a spiral galaxy and boasts 4 arms protracted around supermassive black hole dubbed Sagittarius, which is located in the center. Astronomers recently found evidence that the Andromeda galaxy, which is located next to us, the Milky Way, has already been involved in several mass-eating events. A study led by Dr. Dougal Mackey from Australian National University, published in the journal Nature magazine, concluded that the Andromeda first went on a galaxy-eating frenzy about 10 billion years ago when it was the first formation stages. 6 billion years later, another instance of such galaxy eating occurred following a number of smaller events. This is according to Sputnik. Now, according to the gravitational waves found again, here's how they could whisper the universe's secrets. This is on The Conversation by Graham Wowan, professor of astrophysics at Glasgow University. The international team of physicists and astronomers responsible for the discovery of gravitational waves back in February announced the detection of a second strong signal from the depths of space. It is further confirmed that gravitational waves both exist and tell us a whole new story about how the universe came to be the way it is. In 1915, Albert Einstein put forth his general theory of relativity, making the bold step of equating gravity to distortions of time and space caused by the presence of mass. He and others went on to predict that accelerating masses would generate ripples of distortion, flowing out as gravitational waves, though it was thought these would be too weak to ever measure. Like the first detection, this second fleeting signal came from two black holes in a tight orbit, what's known as a binary black hole system. And after spending many millions of years orbiting each other in ever-decreasing circles, these black holes collided in a fraction of a second over 1 billion years ago. They had total mass around 3 times smaller than in the first detection, roughly 22 times the mass of our Sun. But once again, the collision shook the structure of the universe so violently that we detected the waves of stretching and squeezing space and time as they passed through us at the speed of light on Boxing Day last year. Even so, this did not produce the kind of clearly visible waveform that heralded the first detection. It only stood out strongly once processed by software the team developed over many years to extract the maximum amount of science from our 3 gravitational wave detectors. The 2 that comprise Advanced LIGO, Laser Interferometer Gravitational Wave Observatory, LIGO for short, and in the US, the Advanced Virgo in Italy. Questions and possible answers. The existence of 2 black holes with such high masses came as a surprise to many astronomers at the time of the first announcement, since the formation routes for such black holes are unclear. It was in fact the first direct evidence that binary black holes exist and can collide and merge. The existence of massive black holes raises many questions. Were they formed in the Big Bang or through a collapse of matter at the later date? Did they form from a pair of supermassive stars, or did they join together by chance once the stars had become black holes? Are they related to the formation of the supermassive black holes that appear to exist in the cores of nearly all galaxies, like our Milky Way galaxy, the Sagittarius black hole? And what are the implications of the collapse of matter into stars and galaxies and the formation of structure in the universe? When it comes to answering questions such as these, the number of events we see is important. Everything we have seen to date was a result of the inaugural 4-month run of Advanced LIGO, 2 spectacular deaths of binary black hole systems, and possibly also a third, though the signal is not strong enough for us to say with certainty. The tantalizing implication is that we will see many more in the future, and this would let us see the full range of masses of binary black holes, and also how rapidly they spin and how their spin axes are aligned. These are crucial factors in determining how black holes are formed. As if that wasn't enough, these signals give us something else. It's basic, but it's astronomy. It is a very highly prized number in the distance to their source. There are remarkably few reliable ways to measure the biggest distances in the universe, and gravitational astronomy provides one that is entirely new. As the field advances and new telescopes become available, this could help us map the expansion of the universe and examine the elusive ideas of dark matter and dark energy that run through current cosmological theories. When the Advanced LIGO detectors return to operate towards the end of the year, it will be with even greater sensitivity, and they will observe for longer, this time in conjunction with Advanced Virgo. As a result, we can reasonably hope to see approximately 10 further binary black hole signals by this time next year. By 2018, we predicted that we will see many tens, maybe even hundreds of such signals, allowing us to study the population of these enigmatic sources more deeply. The improved sensitivity and the third detector in Italy also open the door to even more exciting discoveries to come. We're hoping to observe gravitational waves from neutron stars. These are the remnants of low-mass stars whose lower gravity prevented them from collapsing all the way back to black holes. Unlike a black hole, a neutron star is a highly compressed ball of nuclear matter, and its detailed structure is set by particle physics. Observing gravitational waves either from single neutron stars or binary pairs would reveal the physics of matter under the most extreme conditions in the universe. Having 3 detectors working in conjunction will also mean that we can be more accurate about the position of the sky from which a wave is coming. That will help us to identify any signals from these sources seen by conventional telescopes, the flash from the collision, or its aftermath. This will multiply the scientific return from both kinds of signals many times over, for example, by giving us more insight into the structure of the universe. And looking ahead a few years, we will have space-based gravitational wave observatories of the kind pioneered by recent highly successful LISA Pathfinder mission, which announced its own astonishing performance results earlier in June, and this would allow us to see a new spectrum of sources at lower frequencies, but could also reveal these black hole binaries earlier in their lives and allow us to follow them for years before they finally coalesce. In short, the spectacular results from this first short run of LIGO are just the beginning of gravitational astronomy. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.